All right, welcome to Unit 1, Function Analysis. In this video, we're going to talk about the average rate of change between 2 points on a function. So this is actually a really important topic, and it's a really easy one, so it's kind of cool that such an important topic is easy. It's going to be a big, this idea of rate of change is a big idea when you get into calculus. But let's talk about what exactly is we're looking at here. Now, I also want to note before we move on is that rate of change is really just a fancy way of saying slope. So slope is something you learned way back in middle school, maybe, I don't know. But rate of change is just more of a sophisticated way of talking about the slope. All right, so let's talk about what I mean by the average rate of change. And there's a whole lot that we got to talk about with this very simple definition here. So for a nonlinear graph whose slope changes at each point. Let's actually stop right there at that comma. What do we mean by for a nonlinear graph whose slope changes at each point? Why do I need to say that? Well, let's talk about why it says a nonlinear graph. Because a linear graph, a graph that might look like something, I don't know, something like this. There's a line, right? A linear graph, the rate of change, slope, is the same at every point. Any point on this green line has the exact same slope. It's whatever the slope is. Let's just say that that was y equals 2x plus 3. Well, at every one of those points, the slope is 2 because the slope of that line is 2. So it doesn't matter what 2 points you're talking about. It doesn't even matter what 1 point you're talking about. The rate of change, the slope, is always going to be 2. So for linear graphs, the rate of change is always the same. It's whatever the slope of the line is, so it's pretty boring. So we're talking about nonlinear graphs who have a slope that changes at each point. Now, what do I mean by changes at each point? Well, let's take a look at this extremely nonlinear graph down here in the bottom right-hand corner. If I pick any 2 points, for example, this point right here, and then maybe this point right here, you will notice that those are obviously 2 different points. We could call it point 1, P1, and point 2, P2. But what we notice is that if we talk about the slope at each of those points, there is a very, very different slope, or again, rate of change. So for example, if I were to draw a tangent line, now a tangent line is a line, if you go back to thinking about circles, a tangent line just touches the outside of the circle. So if I were to think about drawing a tangent line that crosses through that blue point and only that blue point, I get a line, right? And you can see the slope of that line is clearly positive. Well, check this out. If I were to draw a tangent line at this point right there, that again crosses through that blue point, you'll notice that it has a very different slope. It's clearly negative at that point. So the idea is that we're talking about nonlinear graphs. Hopefully you understand why. Linear graphs are boring. They have the same slope. But we're also talking about graphs where the slope changes at each point. And this is a great picture where you can see that the slope is different. So now that you know what we're talking about, we can continue on with this, right? So for a nonlinear graph whose slope changes at each point, here we go. The average rate of change between any 2 points is the slope of the line between those 2 points. And that's why I was telling you guys that this lesson is very easy. So if I were to connect these 2 points with a straight line, there it is. There is a line. The average rate of change between the 2 points, P1 and P2, is simply the slope of that line. Now, we call this type of line a secant line. Go back to unit on circles back in geometry. A secant crosses a circle twice. So notice I crossed the graph here and here. I have the 2 points. You would say, well, wait a minute, you're going to cross the graph again. I realize that, but I'm only looking at 2 points at a time. So you might draw a line that crosses a graph 3, 4, even 5 times, but we're only looking at 2 points at a time. So if I look at the line that's produced by P1 and P2, the average rate of change between those 2 points is nothing more than the slope of that line. And that's easy, right? How do you find slope? Well, here's a point, x1 comma y1. So there's point 1. And here's point 2, x2 comma y2. So to find the slope, come on, go back to algebra. To find the slope, and we actually even write a little SCC here. So the slope of the secant line, right, is subtracting the y's on top and subtracting the x's on the bottom. I mean, it's really that easy. So to find the average rate of change between 2 points of a function, all you got to do is find the slope that crosses those 2 points. It's really that simple. Now, here is the formula right here, and you may look, well, why is that a little different than my formula in green? It's the same formula. Remember, y is, just plugging x into the function. So f of x1 is y1, and f of x2 is y2, because to find a y coordinate, all you got to do is plug the x into the function to get your y. So whether you call it y or f of x, it doesn't really matter. The whole point is that this should be very, very simple. If we create 2 points on any nonlinear graph and we draw a line connecting those 2 points, we're going to get, well, a line. And the slope of that line is known as the average rate of change between those 2 points. It's basically what is the vertical change from point 1 to point 2 and divided by what is the horizontal change. So again, that's the idea of slope. And just for future reference, we call this a secant line, again, because we cross the graph at those 2 points. All right, so let's practice this, because I really want you to trust me that this is very simple. So here is a function, x cubed minus 3x, and the first thing we want to do is find the average rate of change from -2 to 0. So if I were to take a look at this graph, here's -2, here's 0, and I want to find the average rate of change. Well, lo and behold, hey, I have a graph right here. So here's a graph of this function, and at -2, you'll see that there is a point right here, and we're going to find that. It's -2 as well, but we're going to show that work in a second. Here is 0, and what we want to do is we want to say, okay, from point 1 to point 2, what was the average rate of change? So all we have to do is connect those 2 dots and find the slope of that line. So how do you find slope? Well, you need points, right? So I have to find the points. I already know the x is -2 and the second point has an x of 0. Now I need to find the y coordinate. You could look at the graph that I just had, or you could plug it in, right? So -2 cubed minus 3 times -2. Well, -2 cubed is 8. 3 times -2 is -6. Minus the -6 is positive 6. So we get -8 plus 6. -8 plus 6 is -2. -2 cubed is -8. I think I might have said 8 by mistake. -2 cubed is -8. So that's that point that we saw right down here at -2, -2. And the next point is 0. And again, to find the y coordinate, we got to plug in 0. So we get 0 cubed minus 3 times 0. And that's 0 minus 0, which is, of course, 0. That's that second point that we see right here. So now, again, to find the slope of the secant line, all we got to do is subtract the y's on top, -2 minus 0. That's -2 minus 0. Subtract the x's on the bottom, -2 minus 0. And even if you did it in the other order, 0 minus -2 divided by 0 minus -2, you would get the same answer. -2 divided by -2, 2 negatives makes a positive 1. So the slope, the average rate of change, between these 2 points is 1. Very simple. All right, let's try a second example with the same graph. This time we want to look from 1 to 4. So let me use blue this time. So here is the point at x equals 1. The point at x equals 4 is literally way up here somewhere. I can't even see it. My graph isn't big enough to see it, but it's way up there. So if I were to connect those lines, I'm going to pretend that I know it's up there somewhere. I'm going to get probably, and I'm off there, sorry. I'm going to get a really big slope would be my guess. So let's actually go ahead and do the work here. So again, I need the points. So what happens when x is 1? Well, again, go ahead and plug it in. 1 cubed minus 3 times 1. 1 cubed is 1. 3 times 1 is 3. 1 minus 3 is -2. That's the point we saw right down here at 1, -2. And now we need that second point, which happens when x equals 4. So I get 4 cubed minus 3 times 4, excuse me. So 4 cubed, if you don't know off the top of your head what 4 cubed is, which is totally fine, it's 64. So we get 64 minus 12. 3 times 4 is 12. 64 minus 12 is 52. So no wonder I couldn't see that point, because 52 is really high. So again, my graph only goes to 9. The point is way up at 4, 52. So anyway, to find the slope of the secant line, the average rate of change between these 2 points, I'm going to subtract the y's on top, subtract the x's on the bottom, and I get 54 over 3. And you can check and see if that's reducible. It is. 54 divided by 3 is exactly 18. So as I noted in the picture, 18 is a pretty steep slope. We see in the picture that if you're going from 1 to 4, you are going to have a pretty steep slope or a pretty steep average rate of change. All right, let's do another example here, last example here, just to make sure, we see this with a slightly different type of function. All right, so now we want to use this function right here, x plus 2 divided by x squared minus 3x. And we want to look at the average rate of change between 4 and 5. So here's a graph of this rational function. And let's see, I'm going to use blue. So here is a point at 4. Here is a point at 5. And if I connect those 2 dots, you're going to see I'm definitely going to get a negative rate of change, a negative slope. So let's actually do the work to get the actual slope there. So I need the 2 points, 4 and 5. Now this is going to be a little bit more work to do this, but let's take our time. I got to plug in 4 on top. 4 plus 2 is 6. On the bottom, 4 squared is 16. 3 times 4 is 12. 16 minus 12 is 4. So 6/4 reduces to 3/2. All right, now what happens when I plug in 5? 5 plus 2 is 7 on top. 5 squared is 25. 3 times 5 is 15. So 25 minus 15 is 10. So I get 7/10. All right, the fractions is going to make this a little bit tricky, but I have no worries. I think you guys will be good. All right, so on top, I'm going to do the y's, 7/10 minus 3/2. On the bottom, I'm going to do the x's, 5 minus 4. Notice if you go 7/10 minus 3/2, then you have to continue that pattern of 5 minus 4. So the good news is I get a 1 on the bottom. That's awesome. Now I just got to do some dirty work to get a common denominator here. Multiply top and bottom by 5. That way we get a common denominator. So I get 7/10 minus 15/10. 7 minus 15 is negative 8/10. So that reduces to negative 4/5. And divided by 1, it's still negative 4/5. So there's my slope. My average rate of change of that blue line right there is negative 4/5. Negative 4/5. So again, make sure you follow my math there in terms of getting the common denominator. If you want to just use your calculator, type in 7/10 minus 3/2, that's totally fine. But again, I got a common denominator by multiplying top and bottom by 5 to get the common denominator of 10. And that's what gave me 7 minus 15, or negative 8/10. All right, let's do another one here. This time we're going to look from 0.5 to 1. So 0.5 is right around here. Here's a point where x equals 0.5. And here is a point where x equals 1. And I want to find the slope. It's clearly going to be a smaller positive slope. But let's go ahead and do the work to find it. So the fractions or the decimals are going to make this a little bit tricky, but I have no fear. All right, so when I plug in 0.5, so 0.5 plus 2 is 2.5. That's my numerator. And on the bottom, 0.5 squared is 0.25 minus 3 times 0.5. And I get negative 1.25 on the bottom. Again, use a calculator. I'm actually using a calculator as I explain this right now. Use a calculator to make sure you get that math right. And then 2.5 divided by negative 1.25. And again, I'm bad with fractions and decimals too. So, oh, you actually get negative 2. Well, that's nice. That was easy. And there it is right there. At 0.5, we are exactly at negative 2. So my point was actually a little off. It's right there at exactly negative 2. It's nice when things work out so beautifully. All right, and then now we got to plug in 1. 1 plus 2 on top is 3. 1 squared is 1. 3 times 1 is 3. 1 minus 3 is negative 2. So I get negative 3/2. All right, so when I find the slope of the secant line, I'm going to do negative 3/2 minus negative 2, all divided by 1 minus 0.5. All right, so on top here, I'm going to get a common denominator by multiplying by 2. So I get negative 3 plus 4. That's going to be negative 3 plus 4 is 1/2. So I get a 1/2 on top. Again, grab a calculator if you need to, right? Negative 3/2 plus 2. Well, I'm looking at 2 as 4/2. So negative 3/2 plus 4/2 is 1/2. Negative 3/2 plus 4/2, which is 2, is 1/2. I'm just going through that so you can take the time to make sure you understand that, because a lot of kids struggle with fractions. On the bottom is 1 minus 1/2. 1 minus 1/2 is 1/2. And this actually works out to be pretty easy, because 1/2 divided by 1/2, or if you want to multiply by the reciprocal, 1/2 times 2 is 1. So the slope of this green line is a fairly simple rate of change, which is 1. So this whole video is done. It's basically over the average rate of change between 2 points. So all you have to do is find those 2 points, get those 2 points, and do all the dirty work to find the slope between those 2 points. But instead of calling it the slope, we call it the average rate of change. All right, that's it. Very, very easy property of functions, the average rate of change between 2 points.